So let's roll again. Thank you so much for joining our stream. I believe there are a lot of geologists here today, and welcome. Thank you for joining today. For those that attend our stream for the first time, I just want to make a quick introduction. My name is Anya. I'm a business development manager of K-Mine, and today we'll have a little different stream than usual. If you previously attended our stream, you know that before we showed you guys high-level features of our previous models, maybe our use cases. By the way, if you're interested, feel free to check out our LinkedIn page and YouTube channel, where we posted the recordings of all the previous streams, and we will post the recording of this stream as well. All right, so today, we actually gonna show you guys a specific feature that we about to release, I think, in a couple of weeks. We're releasing this feature inside of our geology model. And you might already know that because of the name of the stream, we're talking about stratified block model creation or SIM model creation. Different companies call it differently. And today we have, if we have geologists from Canada, you might recognize our guest today. It's Pierre Lafleur, who is independent consulting based in Canada. Pierre, do you hear us?
Yes, I'm sorry, I was muted. Yes, thank you. Hello to everybody.
Great. And also here with me, Tatiana Nestenko, who works as a senior geologist at K-Mine, and she will answer your questions in the end of the stream. Tatiana, do you hear us?
Yeah, hi everyone, a pleasure to be here.
Thank you. So you might already notice that during this stream we'll conduct various polls. Please participate in them so we can enhance our future presentations and we can keep improving our product. In case you're already familiar with our solutions, you know that during over 25 years of operations, we created various models for open pit and for underground mining. The fact that K-Mine has this model structure allows us to be available for any size of business. Plus, this way we can offer flexibility and opportunities for basically unlimited scale for each of our model. And in general, we aim to automate all the processes as much as possible with our flexible scripting tools and, of course, our own graphic core. So currently we cover open pit and underground mining with our 12 models and customized add-on. Obviously, we're going to talk today only about one part of geology model, but it's important to do just a quick overview of things that you were able to do in our geology model even before this release. So the existence functionality of core, exploration, wireframing, block modeling, geostatistics, all of this functionality allowed us to have a geology model that was one of the most powerful solutions in our product. So overall, when a user works with this model, he usually goes through several stages like creating a database, statistical analysis, interpretation of geological data, 3D modeling, resources and reserves estimation, and so on. In general, our system includes several classic methods and 3D methods to calculate reserves. Among them, of course, the method of the nearest area, also called Tyson polygonal method, of course, geological blocks, vertical sections, statistical and geostatistical methods. Of course, when we talk about any successful mine development, estimation or like estimation of mineral resource is basically a starting point. There is a whole list of factors that contribute to a reliable estimation. That includes relevant data, good quality data, of course, competent geological interpretation, and methodology that is used for data interpretation plays a very important role, and adequate representation of deposit geometry, grade distribution, and its density play also important role in the accuracy and reliability of resource estimation. Now, when it comes to deposits that consist of multiple layers like coal, the creation of their viable geological model is often so time consuming that without necessary tools to create an effective coal resource model from drill hole data, this process might take weeks, if not months, especially if first you need to create a wireframe model for each layer, and if deposit consists of multiple coal layers, that complicates things even further, because seams correlation requires a clear understanding of the data on plans and in sections and also in 3D. So in the end, of course, it's all paid out with a solid base for effective mine planning. However, to provide maximum convenience and efficiency working with models of layer deposit, K-Mine created a new block model type, which is seam block model. It's different from regular block model because the size of blocks by their height or z-axis is variable. You can build and quickly update such types of block models with the new operational exploration data. So you basically can update it on the go, and that's why this method is so useful for users. So right now, let's see how to build seam block model in K-Mine. The main thing in this creation process is to prepare a database correctly, properly, and simulate the marker horizon and tectonic structure of the deposit. So first, we're creating a complete reference table based on the existing geological database. We input chronological sequence of seams, and if it's required, we can index individual interlayers during the process of seam split. So then we need to add to our reference table intrastratal rocks, or you can call it interlayer intervals of enclosing rocks. Each interlayer must have its own unique code. So that's why when we add intervals, we use suffix or prefix in the name for overlying or underlying layer. So we can keep filling up the database manually, or and we always start the filling up process with colors table. So you will see on the video this process. We just click add record, and ID record is created automatically in the table. It is a unique number. For example, in new drill hole with ID 555 appeared. And then when we go to the detail table, which is a survey and asset table, we click add record and see that this record appears in a detail table, and we just add some data. So you can see that we established the connection between the primary table and unique number of intervals by the ID. So we can also add some data from properties of graphical objects directly to the database. For example, on the video, we selected some point objects that can be just technological samples. And what we need to do is to set correspondence between fields in a database and property of the object. So we're setting X, Y, Z, or Z, how Americans say Z coordinates in the colors table. And we can add a new row for assay table and set some values, for example, ash. We can also import data from Excel file. We just need to select the required database in the connection list, and in field open file, we just select Excel file to import its data. And we're migrating colors, survey, assay table by dragging files from tables of important files to the field area of the database table. And then we just connect Excel file columns with the database columns. And we can also transfer certain sheets from the source file by dragging the required rows. So users also can sort and filter data in the database. Basically, you just have two options in each table of this row. You can either use a drop-down list or use a custom filter. And user can filter the data by depth range. So you can see on the video in the object position field, we're indicating the location of the created objects relative to the boundaries of the specified depth range. And it has options like top, middle, and bottom. Well, then in the processing type column, we're selecting the current value, and the destination column, we're selecting depth. We push OK, and you can see that object marks were created from the database, and they contain Z marks values of the seam, roof, or floor, or bottom. So then we just open the layer editor and select point objects to create a seam floor wireframe. And once the first stage of seam block model creation is done, we can see a new type of block shape. You can see on the slide that just a quick change of slides. Okay, great. So you can see on the slide in the middle that that is the block model shape existed before in KMI, which is a cube-shaped block. The new block shape is a prism with 4 points on the perimeter and 1 in the center of the base. You can see it on the left side of the screen. And comparing to HARP model from Vulkan, the block also has 10 points and center point. And this type of 11 vertex block helps visualize seam morphology with high precision. So once we define all the layers of the mineral deposit and all of it enclosing rock interlayers, we need to set the marker surface where the seam model will be automatically created. And to create this marker surface, we use intervals of marker horizon intersections in the geological database as source data. So you can actually register the seam sequence of the future model in 2 ways. The first way is to create the rock reference table when you upload the data into the database, or you can change the sequence of the strata when you create in a block model. So you just need to drag some layers to the sequence field and then save it to the filter. It's convenient in case you get new interlayers when you get new data. So now we can open a filter editor of seam sequence for this deposit. And we need to limit the construction area of the seam block model. In order to do that, we need to create a solid. And as construction boundaries, you can count a technical boundary or a license contour of the deposit with the simple tectonic structure. And for the deposit with applicative and disjunctive tectonic dislocation, faulting zones, and topography wireframes would be counted as blocks boundary. So we can also save block solids and marker wireframes in the filter and use them later. So we're selecting points in the layer editor to create a marker horizon. And also you can use additional seam points of the roof or floor intersections in underground workings or in excavated areas in the open pit. In other words, user just needs to create a marker horizon and save it in the layer editor. So each marker surface is automatically saved in the layer editor to the corresponding sublayer with tectonic block number. As a result, you can see that the marker surface is created for each tectonic block individually, and each of these surfaces covers the entire simulated area. The marker surface is usually taken as a seam with relatively seam geological structure and maximum variability, meaning that it has the largest number of intersections along the drill holes. So to limit the block model, we construct a wireframe of daylight surface, also oxidation zones, and other specific services that are limiting the seam of the mineral deposit. And in this case, the rule of thumb would be more layer intersections you can specify for calculation and construction, smoother seam block model will be created. And it goes the same for calculations of various block parameters. When you create a seam block model, you can specify the number of adjacent drill holes that are involved in this thickness calculation. So if the simulated area does not have any tectonic dislocations or separate blocks, all its seams can have just one marker surface. All right, so now we're creating attributes for the block model. We're setting up code, zones, category, ash content, moisture content, lower calorific value, and so on, like other attributes. In general, when you create a seam block model, you need to specify block sizes by X and Y axis, as well as to limit the minimum block size by Z axis. So block sizes by Z axis will range depending on the seam intersection thickness of the particular layer. But if you specify the minimum height as, let's say, 0.5 meters, and for one of the drill holes, the coal bench thickness is 0.3 meters, you can find a fault wash on this block model section. That's why it's important to analyze data areas before building a block model. If you simulate the deposit with tectonic dislocations, the marker surface should be created separately for each tectonic block. And before creating a block model with a complex tectonic structure, you need to create boundaries for each tectonic block. Also, interpolation data analysis of elevation marks in marker sim should be performed within the wireframe of each tectonic block. If there is a case of a rare exploration network, or you need to take into consideration the operational data, it's possible to specify the elevation position of marker sim. And in order to do that, you can use things like additional points of the sim's roof or floor intersections in underground mine workings, excavator bucket measurements, bench sketches, lines of sim elongation to the daylight surface, sim's floor isolines in the plan, and so on. You can also perform tasks like create geological sections in any direction, section visualization by the block model in real time, which would include dynamic line shifting of the section by orthogonal planes. By the way, if you create a sim block model in K-Mine, the OX suffix will be automatically added to all blocks of the model located above the specified oxidation surface. The application also takes into consideration the daylight surface set by the wireframe. And if necessary, you can also cut model blocks with leashing, sanitary protection zones, safety pillar surfaces, just by adding the same name zones. So K-Mine's new functionality helps to create sim block models of horizontal and shallow deepened deposits. And it creates it fast and correctly, even if they are complicated by tectonic dislocation. The simulation can be used not only on sim deposits, but also for narrow vein deposits. And the user can display individual coal seams or block distributions by grade, fault, or leaching zones with advanced visualization functionality. In general, it helps analyze each sim morphology and obtain a cross-section in the specified vertical or horizontal plane. And in the end, using the constraints represented by solids or surfaces, it's possible to automatically construct the outcrop mapping for the daylight surface or working horizons. So in order to perform further calculations, you just need to set visible individual models of the model with certain parameters of sulfur content, the plastic property, ash content of the coal, and the yield of volatiles. In general, these new tools help to create sim block models of horizontal and shallow deepened deposit fast, even if they are complicated by tectonic dislocations. And as I mentioned, you can also benefit from our flexible tools for importing and exporting production data, fast updating the deposit sections, even if you get new exploration data. Currently, actually, our engineers are working to expand the functionality of this model. Obviously, we need to solve more complex tasks or in the construction of overfolds and flattens, but that's the functionality we'll talk on another time. And of course, on the sim block model, you can get reports on the area, volume, and tonnage, average cutoff grades, and thicknesses, as well as for regular block models. And basically the same thing. You can get the different reports. So we actually extended calculation functionality, and now you can visualize the required deposit sections and individual seams for calculation using the set property task. So in order to do that in seam reference table, just we are selecting the appropriate positions from the list. And in this example, we're working on the deposit of a complex geological structure. Structurally, it is represented by a centroclinal fold with a flank of a fault slope angle from 10 to 60. And the structure is divided by violations into separate blocks. The span of the flank of a fault shifting is up to 150 to 100 meters. Basically, there is a rock shear zone with a width of up to 100 meters. So the lithological composition is typical for coal-bearing sedimentations. The alterations of sandstones, carbon-bearing rocks, and coals. There are over 15 productive coal seams on the sections, which have alterations with enclosing rocks. And in K-Mine, a user can add physical and mechanical properties of rocks into the database for using the block model to calculate rock mass stability. And basically, rock mass stability in pit walls and section benches depends on lithological composition, also degree of fracturing, rock jointing, water bearing, and rock slope angles. And the weakened zones of enclosing rocks caused by disjunctive violations and weathering zones that are complicate coal mining and directly affect the pit wall stability of the open pit. So you see on the video that you can actually calculate volume, the tonnage of specified section, and the average content of indicators. Same goes to group of calculation results for the required criteria. You can also generate reports and export files to PDF, Excel, XML, or CSV. And you can limit the number of core samples and drill holes during the content interpolation in the blocks. So when interpolating the useful component content in each block, you can specify the number of core samples and or drill holes for calculation. And you can also limit the extrapolation radius to search for core samples in the peripheral zones of the model. So now we set visible only coal seams and calculate block grades and volume. And again, you can also recalculate reserves and resources if you plan with quality requirement parameters, and if you're changing minimum seam thickness, maximum permissible dead rock thickness, ash content, plastic property, or weathering depth. And of course, as this is the case for all K-Mine models, you can transfer geological model data to other K-Mine models, for example, to surveying, scheduling, open pit design, and stability analysis models. Not to mention, of course, print-ready graphic documentation with all of the templates that you can think of that you can customize. And of course, all of these advanced tools allow geological modeling process to be more straightforward, even if you have a complex project. All right, so now I want to give the platform to Pierre, who actually had a chance to use sim block models in various solutions. Pierre, I know that we talked about this type of work that you did in other solutions. What are the main frustrations of users and clients during this type of work?
Yes, the problem is that the geological model is very demanding, and block modeling is not really designed to model geology. The block model approach or methodology is really been created and designed to help mine planning. And so in the case of stratified, narrow veins, thin beds, whatever you want to call it, coal seam, the problem is that in the regular grid block model, you can have, most of the time, you will have only a part of the block that is going to be intersected by a seam. Then you can have blocks with two seams, two different seams, if the blocks are large enough. So determining the size of the block is complicated. Then, even if you can manage it with a 3D block model, and I've done that many times in a standard block model environment, it's the representation of the shape is difficult. You can use wireframe, but a combination of wireframe that's detailed like the one you've shown us with a block model that is useful for mine planning is difficult to achieve.
Yeah,
So
so you mentioned that very often actually a client would not be satisfied with the end result because of different shapes
yes,
of block models.
yes. The problem is that you can do one or the other, but very rarely can you do both at the same time. Have a shape that's visually attractive and accurate from a geological point of view, and at the same time useful for mine planning and scheduling with proper tonnage and information about grade, quality, and so on and so forth. So I have a very software that I know, and I know quite a few, trying to resolve this problem using different approach, different methodology, and to take away from K-Mine as far as I'm concerned. I don't pretend to know everything about every software in the market, but my experience is that K-Mine is highly productive. It increases productivity many folds, and the integration of seam model and a block model with the methodology that you use is very interesting. Actually, I would say it probably match what the market is expecting or hoping for. I know that you're still working on it to improve it. There are some areas you mentioned that other software tried to resolve. For example, truss faults, when you have a repetition of a seam or a layer due to a truss fault or folding. And of course, these repetition can be multiple and not just twice, but 3 times, 4 times. And it becomes very complicated. And so far as I know, it's very complicated still. In most software, I don't know a software that has perfect solution. One of the best software is Leapfrog for managing geology and shapes, but Leapfrog lags behind in terms of mine planning and so on and so forth. So, you know,
Can
there's
it be like too complicated? Can it be like overcomplicated? Is it possible that
Leapfrog is popular because of the geological modeling tools available, and they've included block modeling recently, but not like you have with seam block model. And Leapfrog has no tools for mine planning so far. So what I'm saying, I refer to this software, but I know GEMS and Minex and SERPAC, and I've been exposed also to DataMine, Vulcan, Deswik, so on and so forth. So every software tries to resolve it but there's always something lagging somewhere. And I think the approach and the methodology that K-Mine is using is promising and very interesting because it combines shape and volume. In other words, the information is useful for mine planning directly and scheduling, and it's a good representation of geology, but also the productivity is you can resolve modeling so fast in K-Mine. This is the whole philosophy behind K-Mine, is to provide tools that are very quick to provide a solution. Now, listen to this. Quick solution in K-Mine does not mean that software is easy to use. Because if you have a good piece of software, like I think K-Mine is, then you have to have a very experienced and serious user who will learn it, because K-Mine cannot work like other software that don't provide a solution that is as advanced, say. So in other words, you have to accept that if you're going to use a better software, you will have to spend some time learning how to use it. And I know from the people who use K-Mine that they're very efficient. So that's my take on that.
And I mean, you obviously started using K-Mine, I believe, since January, right? We kind of like started exposing you to our solutions.
Yes.
And as far as our scalability and transparency, how the models can work in the conjunction, what do you feel should be the next step for the sim block model creation? I mean, obviously there are other solutions that we have to cover. Again, it's like our engineers, of course, work on that. But as far as general sim block model creation, do you feel that there is some critical thing that is needed for a geologist to build a sim model, block model successfully and fast? Because of course our automation and our aim is to automate everything and make sure that all of the geologists and all of the K-Mine users can perform all the tasks the most efficient way.
Yes, well, just a quick answer, but very high level. A lot of people are focusing on automation today, and K-Mine is very good at doing that. And then some companies go and talk about artificial intelligence and software or computer learning, whatever. So some degree of intelligence. I just want to say that in automation, artificial intelligence, computer learning, all of these methods are product of human endeavor. There is a human programmer behind it, okay? There's a lot of discussions and people are concerned about automation taking over or not doing it right. Well, talk to the programmer, because behind every piece of software, there's a programmer. And what I find amazing at K-Mine, okay, is while I know many software companies have a lot of staff that is maturing or growing old or whatever, I have not seen many companies today in the market with filled with young people with so much energy, so much ideas, and so much skills as K-Mine. That's my take on that. So talk to them and see what they can do. Now, this sim block modeling tool that is new, we'll have to see how it fares in the market. Right now, it's well done, and I clap my hands because it's going to resolve simple cases. Now, when you have folds and faults and more complicated model, the approach, the classic approach of all engineers is that you break down the problems in different parts. So with a tool that does not cover the most complex task automatically, you basically break it down in different parts. resolve each part separately. Now, to tie the parts together so there's some interaction requires more skills. And I think K-Mine has the skills to develop that. So I invite everybody using other software or K-Mine to communicate with K-Mine their ideas. And I'm very confident that they will be able to synthesize a solution eventually, if a solution is possible. But yeah,
I mean,
yeah.
There are a lot of workflows that I believe each engineer kind of like set up for himself. I mean, obviously it depends on what kind of company he's working in, but basically usually people jump around from application to application just to kind of like save here, save there.
Yes.
But some of the tools are more efficient here, some of the tools there. So for instance, there are users that can use Vulkan, right? But for pit optimization, they use something else because basically they don't need it all year. They don't want to be locked into the functionality that they don't use. And it's not that I'm trying to kind of put down Vulkan, because that's of course very
Well established solution.
solution. Yes. However, this point of K-Mine that we have this models that can work as a standalone models, and they can also work in the conjunction. How important is that for geologist and for just mining engineer as well? I mean, I know that you're working also with underground and with underground mining, with open pit mining, but how important is that we have like one single database and this transparency of the models, when you kind of like just can subscribe to models, and the basically update is set of tools that you have in your interface. You don't need to switch between interfaces.
Yeah, well, this is the holy grail, and as far as I'm concerned, the integration that K-Mine is doing with the software package overall is to me unique and very, very important. You know, we have been around for thousands of years. We've known how to dig rock to build pyramids, and thousands of years ago, all around the world. Every people in the world built pyramids and learned how to cut rock without dynamite and without computers. And then we built cathedrals and incredible stuff in the last few hundred years. But computers have been around for such a short time, one generation. So we're just at the start of this. And if you ask conceptually, you know, a geologist would like to be able to do the expression all the way to extraction and mining, and work with the mining engineers. No, nobody can cover everything and do everything at the same time. But K-Mine, as far as I'm concerned, is able to cover a lot of ground. For example, K-Mine has a module for ventilation. I have discussed with every software company in the world. They always wonder if they should add ventilation or infrastructures. I've been drawing plants and mine offices and infrastructures using either AutoCAD and importing it, or using features, you know, in a block model software, using lines and so on and so forth. It's ridiculously long and tedious, you know. There's shortcuts, but you need to jump around in different applications, and that's a big waste of time. So integration is very important, but the Achilles heel, or the weakness of integration, is that you have individual modules that are good, but not as good as standalone. So there's a software like Whittle, for example, that's very powerful, but then nobody thought you could use Whittle for seam models, or like you have in the seam model, block model in K-Mine. But I did, and it's possible. It's always a question of finding a trick. But what you want is you want users to have be able to do the work easily and not use tricks or call on experts all the time. So I think K-Mine is well positioned right now with this new tool they're adding to their software and their general approach. And that's basically what I have to say about that. And productivity, productivity, productivity. This is what it is all about. If you study theory of constraint, you know, a chain of a chain is never stronger than the weakest link. So integration is very important, but you have to spend, you know, to spread the effort in all the modules. And I see that in K-Mine. So, yeah.
I just want your comment on one question. I mean, it's not a question, it's more like just observation from Richard Flynn. He said, I typically build models in Leapfrog and then use LF Edge to create subblock models for export to mine planning software. On most teams, there is a seldom a single software for usage between geology and mine planning. I'm always skeptical of the data mine dynamic Z subblock feature that is not transferable to any other software. My opinion is that this feature is in fact a limitation. What is your opinion on that?
Okay, I have to leave for another important meeting in a few minutes, so I will give you a quick answer, okay? Data mine is not very good. I've worked with data mine for a long time, since the beginning. I worked with the company, I was Glencore, but it was Falconbridge, and we had data mine. And sub-blocking in general is garbage as far as I'm concerned, but this would take a long discussion to discuss about. I'm favor the approach of using percentage. You can use any block model, including the block models in K-Mine or any block model software, using percentage instead of sub-blocking. I have no clue why people go to sub-blocking. It just makes your life miserable, complicated, consume time, increases the difficulty of sharing the data with other software that have different features that don't work with sub-blocking and so on and so forth. So, I mean, that will have to be a session on itself, and when we talk about block modeling some other time. But of course, if you offer sub-blocking, like CertPack, for example, can read and write data mine blocks and so on and so forth. So Evolve can also use sub-blocking. So if you have software that can do both, that's great. But even if CertPack can do both, usually users use sub-blocking for whatever reason.
Right. Well, thank you so much. I want to let you go because you have another meeting, but thank you so much for your time. Thank you for
it's a pleasure.
Support. And so that was independent consultant Pierre Jean Lafleur from Canada. Thank you so much, Pierre.
Thank you. Thank you so much for inviting me.
Well, now we see that we do have some questions here. I want to give the floor to Tatiana, as she's the one that will be answering questions. Tatiana, do you hear me?
Yes.
Okay. Great. Well, I know that we have a few questions here. One of the questions is K-Mine software able to do both explicit and implicit modeling?
We have only implicit modeling now, so implicate modeling is now in development stage. And symblock model is constructed using the inverse distance Wason method, and cubic block model is created based on explicit modeling.
I know that the implicit modeling actually right now in the end of its development stage. So guys, if anyone would be interested actually to play around with implicit modeling, feel free to message us, because we would be interested to try it out and improve it as much as we can while it's in development. So let us know if you're interested in that. All right, so the other question is it possible to do a simple database such as Excel or Access to work in K-Mine?
Oh, yes. Of course, you can import your Excel document to database directly in K-mine.
And how's the quality of the plotting?
Using the preprint processing integrated in K-mine, you can create any format of templates for printing.
And is there any way to link my local database access to K-mine, or can I also import Excel file contain my data?
There is no direct connection with the database in Access. It is possible to import data from tables, since it's necessary to maintain a certain structure of the database, including reference books, reference tables.
Actually, Len is asking, is it possible to receive the recorded video of this session? Everyone, we post usually all of our recording videos on our YouTube channel and on our LinkedIn page. So yes, we will definitely share the link of the recording video. Well, the other question, let me see. Okay, so somebody asked if K-mine is eligible for open source coding. I believe we not like our API is not open, so we cannot open our software for integration. Am I correct?
Yes.
I believe.
No, maybe in this case, I will try to help you. No, we are not an open source software, so it's not impossible like to contribute for us. So the answer is no.
Thank you so much. That was actually Nikita. He's my partner, and thank you so much for helping us out in that question. Well, I think that's basically it. I want to mention again that we will release this functionality within the next couple of weeks. If you're interested to try it out, please contact us. You can email us to hello@kmine.com, or you can send us a note in the chat of this Zoom session, and we will get back to you. But I think that's it. Thank you so much for joining. Thank you so much for our participants and our guests. Don't forget to follow our LinkedIn page, and I hope to see you guys again in our next live event. Bye.
Thank you. Bye.